Hello and welcome everyone. And thank you very much for joining. I'm Owen Out Essing and I'll be talking to you about what data centers are and how they can help the green revolution. Before I get started, I want to provide a bit of information about myself. I have a background in mechanical manufacturing engineering. I did both my bachelor's and master's at Trinity College Dublin. After graduating, I moved to the Netherlands where I worked as a cryogenic engineer. Here, I created tools that were used to aid the design process of cryogenic valves and couplings. After this, then I moved to Dublin in 2020 to start a PhD in data center server cooling technologies. Now, that's enough about me. What am I here to talk about? Well, I want to answer three questions with my presentations. First, what is a data center? What do they mean to Ireland? And what research is being done on them? So, when you go into Google and you type in what is a data center, the definition you're met with is a physical storage center for the online and digital world. And you get images as we see here. And these images on the left and right, what we have are server racks. And what sits in them are servers, and servers are effectively computers. And these computers are what enable or do the work for data centers. But still, that seemed quite abstract to me. I didn't quite understand what services were they actually providing to us. What data centers are enabling is that first Teams call that we have in the morning when we're sending emails to one another, or even in our downtime, if we're, say, watching Netflix or YouTube, that is all being enabled by a data center. Our current conference that we're having here at the moment is enabled by data centers. I'm transmitting information from my computer to a data center, and that is then distributed out to everyone joining us here today. The more information or the more data that we want to send, the more data centers we're going to need. Because we're sending more information, we need more places that can process that information. Just to give an overview of kind of where the major data center hubs are in the world, this graphic here shows the data interconnectors that we have across the globe, and these are generally located where lots of data centers are generally located near these cables. So you can see there's a large concentration in North America and Europe, and Ireland is kind of located between these two major markets, which is why we see a lot of data centers here in Ireland. A secondary reason is Ireland has a very good climate for data centers. It's neither too hot nor too cold for them. So what does it actually mean for the Irish data center market? We currently have 77 data centers in operation in Dublin that equates to about 900 megawatts of power capacity, which makes Dublin the largest data center city in Europe. Currently, data centers in Ireland consume 11% of Irish electricity, but they consume it in a slightly different manner to other sectors in Ireland. So, in a study I was part of, we mapped out the typical electrical energy consumption in Ireland over a day for the entire year of 2019. So, here we have a typical day, and the blue line maps out the total electricity consumption, and the grey horizontal line along the bottom shows the electrical energy consumed by data centers. And we can see that the data centers are very stable. They tend to use the same amount of electricity all day long, and it's very predictable that way as well. As I said earlier, the society is becoming more reliant on data centers as we want to send more information. Because of this, we're expecting the industry to grow, and in Ireland, data centers will use 19% of the electricity generated by 2026. This can bring challenges going forward as you're getting a relatively large, unflexible load on the grid, which can cause issues going forward as we're transitioning to renewable electricity sources. However, data centers do bring some benefits. In 2020, computer-related services represented 55% of exports, which equates to about 140 billion euros a year. Here we have a headline from the Irish Times which shows that exports increased during the pandemic because of trade in IT and pharmaceuticals. So what this shows is it's a relatively large industry within Ireland that's looking to grow. It brings in some financial benefits. It does have some challenges faced ahead. So combining all of these actually makes it prime for research to be conducted in the area. So some research that is being conducted is what we would call research in adaptive loading. So as I said earlier, they tend to be very static in the load that they, or very non-flexible in the load that they demand. So they tend to not change day on day. But research is being conducted in looking into data centers being able to turn up and turn down as necessary to reduce their load or the demand from the grid. Does require partnerships between both grid operators and data centers for them to both be in communication with another in order that they can maximize benefits for themselves, for each other, sorry. Other research that is being conducted is in software refinement, so implementing machine learning algorithms to try reduce the energy consumed for cooling. This is quite a large sector as cooling can represent up to a third of the entire energy used by a data center. And then we lean in a bit more to where my research is more in the field of optimizing cooling strategies. So I'm going to quickly run through three major cooling strategies I utilize. Here we have a traditional cooled strategy, which is air cooling. We're looking at the internals of a server. And what happens here is you have 6 fans in the image, and they will blow cool air over the hot components to cool them down. That air then heats up, is brought elsewhere, cooled back down again, and returned to the server. And just to give for a sense of scale, the fans that we see in the image are roughly this size here, as the one I'm holding in my hand. So that's about 4 centimeters by 4 centimeters, just to give a sense of scale how large a server may be. Another methodology which is used is called indirect liquid cooling, and this utilizes, as you can see, 2 ports in the rear of the server. We bring in cold fluid via one of the ports. That goes over all the heat generating components to bring down their temperature, and then the liquid heats up over time, goes out the back of the server to the other port, is cooled back down and returned to the server. Then a third strategy which exists is called direct liquid cooling. Here we submerge the server in a dielectric fluid. The fluid is non-conductive, so it doesn't cause harm to the server, but is in direct contact with any components that are generating heat, so you can cool them more efficiently. It works in similar to the other ones, that the liquid heats up over time, it is brought away, cooled down, and then returned to the server. By optimizing and getting better control of our cooling strategies, it enables the potentials for energy to be recovered in data centers. Now, what do I mean with this? First, the way data center typically runs, or traditionally runs nowadays, is we see here 5 server racks in gray. That's where the servers sit. They produce the heat. They're cooled down, and as I was saying earlier, either be air or liquid is brought away, cooled back down. But the heat that is captured by this liquid is then brought to a cooling tower and dissipated to atmosphere. Because for a data center, the heat is considered a byproduct, a waste product. They currently have no use for it. So by having better cooling strategies, we actually enable us to recover this waste heat. And an idea of how this could be implemented is by connecting a data center to a district heating network. And what this enables you to do is you take the waste heat from a data center and it can be brought into people's homes to heat their homes. It can also be brought into industry, say a manufacturing site, which can utilize that waste heat during a manufacturing process. So you can net end up saving energy because say a boiler no longer has to run in a house, whereas it would if it wasn't connected to a data center. This is something that's currently being investigated in Ireland. There's a pilot study going on in Tallaght where they're looking at taking the waste heat from an Amazon data center, shown in orange in the image, and is currently being used to heat a public pool and public library. Going forward, if the scheme is successful, the waste heat can be brought into private sector homes as well as the Tallaght Hospital. So the reason that this brings potential to reduce the environmental impact or to reduce the net energy consumed is data centers will continue to need large amounts of electricity to operate the servers. But by recovering the waste heat, we can net reduce it, as say the boiler in the hospital no longer has to run, as it can get waste heat directly from the data center. Even as we transition over to heat pumps, which are a more efficient technology, they can also reduce their energy consumption by using heat from the data center rather than having to use other sources. So the reason it saves energy is that this energy being considered waste by data centers isn't used. So by giving it a second lease of life, we're actually reducing our net overall energy consumption. Yeah, and here are some references of any sources I quote. Thank you very much for listening. If you have any questions, please feel free to reach out to me either via email or LinkedIn. Thank you very much.